try to understand moment of inertia. Okay. If we have a plane figure, let's say this is a plane figure, and we want to know what is the moment of inertia of this particular figure about any of the axes. Let's say about either x-axis or about y-axis. Okay. And as I have shown on the figure itself, that our plane figure is between two axes. And how we actually calculate its moment of inertia, we basically divide this whole area, this whole plane figure area, into number of strips, right? We divide it into number of strips. Let's say here we have divided it into a number of strips, and one of the strips is this, which I have marked with sorry, green, which is here marked with green. And I want to know the moment of inertia about x-axis and y-axis of this particular figure. Okay, and what I have done, I have basically divided the whole plane figure into number of strips, and I will firstly check what will be the moment of inertia of this particular elemental area, which is a strip. And let's say the area of this elemental element is dA. It is the area of the strip. It is dA is what? Area of strip. And then we will say that this strip of area is at a distance of x on x-axis from y-axis. Okay. And we say we have considered this center of gravity. Let's say we have considered the center of gravity somewhere here, and we say it is at a distance of y from the x-axis. Okay, this elemental area is at a distance of x from x-axis, and y from is at a distance of x from y-axis, and a distance y from x-axis. Now x is your distance of gravity, center of gravity of strip on x-axis. Okay, and your y is, again, it is distance of center of gravity of strip on y-axis. Now, as we have already mentioned, how we can actually calculate the moment of inertia of any strip, right? If we have to calculate the moment of inertia, it is simply mi of strip on y-axis will be given as mi. It will be product of the elemental area and the square of the distance from the y-axis. We are checking it on y-axis. Okay, from y-axis we have a distance of x. Okay, if we have to find out now moment of inertia of whole area, it will be simply integrating it between the two limits, right? Moment of inertia of whole area, that will be simply integral of dA dot x square. Okay, now this was with regard to what? This was with regard to y-axis. This was with regard to y-axis. Therefore, we can easily say our moment of inertia about y-axis is equal to, it will be simply summation of area dA times x square. This is your moment of inertia about y-axis. Moment of inertia about y-axis is equal to summation of the area, total area multiplied by the distance from the y-axis, which is x square. And similarly, if we have to calculate moment of inertia about x-axis, it will be then equal to summation of again area times y square. Okay, it will be summation of area, elemental area times y square. And this is the method by which actually we calculate the moment of inertia of any plane figure. Okay, now this was regarding the moment of inertia. Now there has been a few, two theorems on these moment of inertia, which we will discuss. First one is theorem of perpendicular axes. We have two theorems of movement of in order to calculate the moment of inertia. One is a theorem of perpendicular axis and another is parallel axis theorem. Okay, we have two theorems which we have to discuss in order to understand moment of inertia, and they are theorem of perpendicular axis and the parallel axis theorem. Uh, Firstly, we will be discussing what is theorem of parallel perpendicular axis. Now, for example, let's say we basically consider we have this lamina and we want to check somewhere we have a smaller laminar. Let's say it is of its point P and it has an area of dA, small dA. And this smaller lamina is actually between two coordinates. Let's say that coordinate is x-axis, y-axis, then we have z-axis. Okay, and let's name this point as O. And this smaller lamina, which is point P, it has an area of dA, as I have already mentioned, and it's between the coordinates of x and y are ox and oy. Ox and oy are the xy coordinates, which are actually they are mutually perpendicular on the plane. Okay, they are perpendicular on the plane. OX and OY are mutually perpendicular to each other. Okay. Now what we do? Now we consider one again. We consider a plane OZ, which is this one, perpendicular. Again, it is perpendicular to OZ, which is again perpendicular to OX and OY. Okay, this is one more plane OZ, which is again perpendicular to OX and OZ. That means all the three axes are mutually perpendicular to each other. Simple. All the three axes are mutually perpendicular to each other. And here again, OZ is, it is, this plane is also perpendicular to OY and OP. Sorry, OX. Now let's say this smaller lamina is basically at a distance of x from y-axis, and it is at a distance of y from x-axis. And now its resultant is r from point O. Okay, and then from the geometry we can say that r is basically what? R is distance of lamina P from z-axis. Okay, such that we can say our OP is small r. And from the geometry itself, we can say r square is equal to x square plus y square. Right? We can simply say r square is equal to x square plus y square. And we also know moment of inertia mi of lamina P about x-axis will be given as, it will be simply given as we already know, if we have to calculate Ixx as we have earlier done, it is the area, elemental area. How much is that? That is dA of lamina P, right? Multiplied by distance. Now, which distance? If we are talking about xx, then the distance will be y square, right? And if we are talking about, similarly, if we say what is the moment of inertia about y-axis, it will be again equal to dA elemental area times x square, right? And then if we have to calculate the moment of inertia about z-axis, that will be equal to dA times r square, right? These are the three moment of inertias about three perpendicular, mutually perpendicular axes. Now, I want to know, when I am talking about an axis which is mutually perpendicular to x-axis and y-axis, then in that case, if I have to simply say what is the moment of inertia about that z-axis, as I know it is dA times r square, simple. And we know that r square is how much? R square is, as I have shown here, from the geometry itself, it will be equal to x square plus y square. It will be equal to x square plus y square, which is again equal to dA times x square plus dA times y square, which is again equal to izz will be equal to ixx plus iyy. So this is your theorem of perpendicular axes. Okay. We can also state the statement as if ixx and iyy be the perpendicular, be the moment of inertia, of a plane section, about two perpendicular axes meeting at O. The moment of inertia Izz about the axis perpendicular to the plane and passing through the intersection passing through the intersection of x-axis and y-axis is given by Izz is equal to Ixx plus Iyy. This is your theorem of perpendicular axis. Now one more theorem, which is parallel axis theorem, theorem of parallel axis. Now again, in this theorem, let's we consider again a strip of area on a circle. Okay. Again, here we have the strip of area on this circle. We have a circle here, and we have considered a small strip of area. Let's say this is a small strip of area. Again, of area dA. Okay, now here what we have to do, we have to actually we want to calculate the moment of inertia about any different line. We are not concerned about the axis when we are actually checking the moment of inertia about any different line. Let's say I have a line, let's say here, it's a AB line. And what I am I desire to know is what is the moment of inertia about this particular line, as I already know that for any circle, right, if I have to calculate the moment of inertia, center of gravity will be simply at center, right? If it is a circle, it will be at the center portion of it, and we will be able to calculate its moment of inertia about any axis, whether that be x-axis or y-axis, because it is at the center. Now I want to know here where my what will be my moment of inertia about any axis AB, right? And again, the distance from the line AB, let's say it is given as h. It is given as h. It is the distance from the line from where I have to calculate moment of inertia, and the distance y is actually the distance of the center about any axis of that circle to the distance of that elemental area. Okay, your dA will be simply equal to how much? What is dA? It is area of that strip. It is area of strip, and then we have y. What is y? It is basically distance of the strip from center of gravity. From center of gravity. And now here center of gravity of this section, of this whole section, is here, and the distance is from that portion, which is the center of gravity of the section circle, up till the distance, up till the elemental area. And what is h? H is basically distance between center of gravity of the section and the axis. Center of gravity of section, center of gravity of section, and axis AB. Now, what we know here is when we are actually about to calculate the moment of inertia of the whole section. Can anybody tell me what is moment of inertia of whole section? About axis passing through center of gravity. It is simply equal to how much? dA times y square of whole section. I am right now talking about moment of inertia of whole section, right? Of whole section about axis passing through the center of gravity. Here, center of gravity is passing through the center point of the dias, of the diameters, which is it is that distance, which is actually equal to moment of area dA times y square. And again, we know the moment of inertia mi of whole section about an axis passing through its center of gravity can be simply again written as Ig. Let's name that as Ig, or Ixx. You can also write that as Ixx, because it is we are checking it on x-axis of where we have center of gravity. It is simply equal to how much? dA multiplied by y square, right? Y, what is y? It is distance from what? The center of the axis up till what distance? The elemental area. Then you can simply integrate it, give the limits, and you can calculate the moment of inertia here. Okay, now therefore what we need here is moment of inertia of section about AB, right? We are desired to get moment of inertia of the section about the axis, which about the line AB. That can be any axis, that can be any line. Now, initially, what we got? We got moment of inertia from where? Of this section about the axis, which was this about the axis passing through the center of gravity, which was this axis, right? Now we want to add this axis. We want to add this axis. It is actually a line which is parallel to the axis passing through the center of gravity, which is this one, right? It is the line through axis passing through the center of gravity, and then we have a parallel line which is somewhere far away at a distance of h from the axis which is passing through its center of gravity. And I want to know what is my moment of inertia at the parallel line which is at a distance of h from the axis which is passing through the center of gravity, and I have to calculate now moment of inertia about that axis. That will be actually equal to IB, which is AB, at which I have to calculate. It will be equal to summation of dA h plus y raised to the power of square. Because my elemental area is this point, I have to calculate the moment of inertia of this elemental area dA about the axis AB. Now, how much is the total distance? It is h plus y, right? Therefore, I can simply write it as dA h plus y whole square gives me h square plus y square plus twice hy, which is equal to summation of dA into h square plus summation of dA y square plus summation of dA 2hy. Okay. Now that will be actually equal to, firstly, h square means it is a times h square. Simple. A is elemental area where you have been integrating it from the different within the different limits, and then dA into y square. As I have already given, it is Ig. That is moment of inertia about the central axis, plus dA into 2y. This is actually 0. Why is it 0? It is actually a summation of dA times y. dA times y, it is basically area multiplied by this distance, which is the distance from the axis of the centroidal axis to the elemental area, right? This is actually what? This is sum of moments of all the areas. It is actually sum of moment of all the areas, right? About which axis? About an axis passing through the center of gravity. Passing through center of gravity of section. which is basically equal to how much? A into y bar. Y bar is what? Y bar is actually the distance of the centroid axis, which is h plus a. That comes out to be, wherein this y bar is basically which distance? It is the distance between this section and this whole section and the axis passing through the center of gravity. Right? What is y here? In this case, I'm talking about this distance which we are concerned about, which comes out to be zero. Actually, it is the distance between the section, this whole section, and the axis passing through the center of gravity. That is same. The distance between the section and the axis which is passing through the center of gravity, which is actually same. That therefore it comes out to be zero. Here y bar which we are talking about, it is which distance? It is distance between the whole section, right, and axis which is passing through the center of gravity. Which is actually zero. That is why this term comes out to be zero. Therefore, we can simply say here our moment of inertia AB is actually equal to Ig plus AH square. This is your parallel axis theorem, wherein you can also state this theorem as it is the moment of inertia of for any axis. Let's say here our axis is AB. The moment of inertia of any area about the axis, it is basically equal to the moment of inertia about a parallel axis, which is this one, parallel axis, but it is passing through the area's centroid. It is passing through the area centroid, which is Ig, plus the product of area and the square of the perpendicular distance between the axes. Okay. Okay, I'll write it down also. This theorem of parallel axes, here the statement you can also write this the statement as if the moment of inertia of a plane area about an axis through its center of gravity is denoted by, oh, you not right, or is denoted by Ig, then the moment of inertia about any axis, here that axis is AB, which is basically what? It is parallel to the first and at a distance of h from center of gravity, then your moment of inertia about that portion AB is actually equal to Ig plus AH square. Or you can also write it this way. When you have this, what we called as, you have to calculate the moment of, you can also write it down, moment of inertia of any area about any axis is basically equal to the moment of inertia about a parallel axis, which is I Ig, moment of inertia about the parallel axis passing through the area centroid, right? This is area centroid. This is passing through area centroid. Plus product of area and the square of the distance between these two axes, that is h. Now we will be discussing the moment of inertia of various planar figures. For example, we have, if we have to calculate the moment of inertia of any rectangular section. Firstly, m for moment of inertia for rectangular section. Let's say we have this rectangular section. It has a width of B and depth of D, right? And these are basically its axes. That its axis, and we name it as A, B, C, D. Okay. Now I want to know what will be the moment of inertia. As I have already written that its depth and width are B and D. Now, in order to calculate the moment of inertia, what we need to do again, an elemental area. Let's say that elemental area is dA. That elemental area is dA, which is at a distance of y from the centroidal axis, right? Because as you know, these are our centroidal axes, because this being a symmetrical, and you can easily see which one will be the centroidal axis. Now you want to know the moment of inertia of any strip, that is this strip which I have shaded as green. I want to know the moment of inertia of this elemental area. Now how can I do that? Firstly, I know that for the area of this strip will be, area of strip will be how much? It has a width of, it has a dA, or firstly it has a B multiplied by, this is width, this is its width, and let's say its thickness will be here mentioned as, if it is at a distance of y, it is dy. That will be dy, b into dy, right? If I have to calculate the area of the strip initially, then we also know the movement of the strip about x-axis. Movement of strip about x-axis, that will be simply given by area multiplied by the distance from that x-axis. How much is that? That is your y square. Area is how much? B into dy. B dot y square. Now, if I have to calculate the moment of inertia of whole section, if I have to calculate the moment of inertia of whole section, I have to basically integrate it within the limits, right? Wherein our y will be within the limits of what? It will be from the lamina from where it is starting, which is it is starting at, if this is your x-axis, it is starting, this distance will be simply d by 2, and again this will be d by 2. That means you have to integrate it or summation within the two limits, which is minus d by 2, which is downwards, minus d by 2, it will go up to plus d by 2, right? If I have to calculate the moment of inertia of the whole section, it will be simply done by integrating the equation within the two limits or the two lengths of the lamina, which is minus d by 2 to plus d by 2. So here our moment of inertia about I-axis, I-XX. I'm not talking about any other axis. I'm just talking about the moment of inertia about I-axis. That will be simply equal integral of minus d by 2 to plus d by 2, right? B. B won't be changed. And then we have y square and we have dy. That will be equal to b bahar minus d by 2 and plus d by 2, that will be equal to y square dot dy, which after integrating it will be equal to y square will be y cube by 3 limits minus d by 2 plus d by 2. Now giving the limits will give you Ixx, giving the value of y as d by 2, right, and minus d by 2. That means you can say it will be equal to b times d by 2 whole cube divided by 3 minus times d by 3 whole cube divided by 3 bracket close. That will be equal to solve it quickly and tell me how much will be Ixx, moment of inertia about x-axis.
D by 2 whole cube. You have written D by 3.
Yes, sorry, it is d by 2.
It comes to be BD cube by 12.
Okay, it comes out to be bd cube by 12. Okay, this is your moment of inertia about x-axis. And how about moment of inertia about y-axis? What can be moment of inertia about y-axis? Again, same, it will be bd cube by 12. This is our moment of inertia about any axis, about any x-axis and y-axis, which comes out to be bd cube by 12 for any rectangular section. Join again now because our time limit is over. If we have a hollow rectangular section, this is our B, and our internal one will be B dash. This is D, and this is our. Hanji.
सर मोमेंट ऑफ इनर्शिया अबाउट y एक्सिस आता है db cube by 12.
In the previous case? Yes. It is db cube by 12. Please correct that. All of you listen, in our previous case where the moment of inertia about I-axis was B d cube by 12, whereas our moment of inertia about y-axis will be db cube by 12. Please correct it. Here now, if we have a rectangle again, but it is hollow. Now, in that circumstances, what will happen? There won't be much changes in this. As for example, if we have d external d, and internal d will be d dash. What you have to do here is when you are calculating the moment of inertia of a hollow rectangular section, what you consider, let's say this is a rectangular section. We have a hollow rectangular section in which ABCD is the main section. Let's say this is our A, B, C, and D. And the internal one, let's name that as E, F, G, and H. It is basically the cutout section, right? This is your main section. The external one was the main section, and the internal rectangular is the cutout section. We have taken out E, F, G, H. Okay, and now we want to know what will be the moment of inertia. Simply, you have to deduct the internal moment of inertia from the external moment of inertia. As from the previous example, we can easily say the external moment of inertia about I-axis will be simply equal to how much? It will be equal to bdq by 12, right? And the internal one will be again equal to Ixx internal will be equal to b dash d dash q by 12, right? And you deduct this external, which is for area which A, B, C, D, and this is for E, F, G, H. Okay, your moment of inertia in this case will be simply equal to b d cube by 12 minus b dash d dash cube by 12. This will be your moment of inertia about y-axis. And if you have to calculate the moment of inertia about y-axis, then in that case it will be db cube by 12 minus d dash b dash cube by. This will be for this cutout section. Okay. Then we can also check for any circular section, right? If we have to see what will be the moment of inertia about any x-axis or y-axis, then in that case, what will be the moment of inertia? Okay, your case third can be moment of inertia of a rectangular section. Sorry, a circular section. Let's say we have a circle and we have to check the moment of inertia of any circular section. Let's say this is its x-axis, and let's say this is its y-axis, right? Again, here if we want to calculate the moment of inertia now of this circle, wherein we have a center O, you can easily say where is the center of gravity. It is simply at the center, right? It is coinciding with the x-axis and y-axis, which is passing through y-axis. And let's say here again the axes are basically primarily they have to pass through the center of gravity in this asymmetrical figure. Now what we do, we consider any elemental area. Let's here, how can we consider the elemental area? It has to be ring, right? Elemental area will have to be a ring here in this case, which is actually having a it will be having some distance from the center of gravity, which is point O. Firstly, let's say it is at a distance of x. It is at a distance of this elemental ring of radius x, and its thickness will be certainly dx. Therefore, in order to calculate the area of the ring, let's mention the actual radius as r. It is the actual radius of the ring. Now we want to know the area of the ring. How will we calculate the area of the ring? Can anybody tell me? It will be simply perimeter 2 pi r multiplied by its thickness, and that will be dx. Area of the ring. Its circumferential. That will give out to be 2 pi r dr. As we already know that whenever we have to calculate the moment of inertia of ring about any axis, whether that be x-axis or y-axis, that is actually equal to, it is equal to area times perpendicular distance, square of the perpendicular distance, which is how much area is now? 2 pi r dr times distance. How much is distance? It is x square. That comes out to be 2 pi r sorry, here it's 2 pi r, it is actually 2 pi x. Please correct it. Parameter 2 pi x, 2 pi x, again 2 pi x, it will be 2 pi x cube times dr. So now when we have to calculate the moment of inertia of whole section, that will be what? About any moment of inertia of whole section about centroidal axis. That will be actually, when we are calculating IZZ, that will be integral of 2 pi x cube dx. Which comes out to be, here you can take 2 pi out and integral of x cube dx. Okay. IZZ will be equal to 2 pi. Please correct it, because I have mentioned dr and r instead of x and dx. Please correct that. It will be integral of x cube, integration of x cube gives out to be x4 divided by 4, and limits will be, now what will be the limits here? X will be, it will be from 0 to R, right? You're substituting the limits from 0 to R. That comes out to be pi by 2 times R4. Okay, and we also know that R is actually D by 2. So in order to bring it in D, then your IZZ will be equal to pi by 32 D raised to the power of 4. This is your moment of inertia of the circular section about the centroidal axis, right? About the centroidal axis. This is the moment of inertia. And here, one more thing which we need to talk about is now with regard to Ixx and Iy. They both will be equal because for the circle your radius is equal in r axis sorry x axis as well as in y axis. You can simply say it will be equal to Ixx will be equal to Iyy, right? So as per the parallel axis theorem, perpendicular axis theorem, we know that Izz is actually equal to Ixx plus Iyy. Okay, we know this. Therefore, you can say that when you have to calculate your Ixx or Iyy, that will be actually equal to pi by 32 into d4 divided by 2. So your Ix's and Iyy will be actually equal to pi by 64 multiplied by d raised to the power of 4 will be equal to Ixx will be equal to Iyy. This will be your moment of inertia about x-axis and moment of inertia about y-axis. And then if you need to calculate the moment of inertia about z-axis, then in that case it will be equal to pi by 34 d raised to the power of 4. And then again, we can also calculate the moment of inertia of a hollow circle, right? Hollow circle again, if we have any hollow circle, what will case for if we have any hollow circle? Again, same trend. If we have two different dias and we will be having only two different dias. Let's say, for example, if we have a capital dia of the outer ring and small dia of internal ring, then in that case, your moment of inertia will be, for example, if we have to calculate the moment of inertia about any Ixx or moment of inertia about y-axis, Iyy, that will be simply equal to pi by 64 multiplied by outer dia raised to the power of 4 minus internal dia raised to the power of 4. This will be your moment of inertia in x-axis and y-axis. But here, one thing is to be kept in mind: the the cutout circle should coincide with, because here if we are talking about internal and external, the center point for both of the rings, whether that be the cutout circle or the external circle, is same. If it is not, then in that case we cannot apply this formula to calculate the moment of inertia. Then we have few more examples which may be symmetrical or they may be unsymmetrical also. Yes, we have to see what will be the moment of inertia of a rectangular, a triangular section, which I probably will do it in next class. So this is enough for today. Okay, Sahil, are you there?